Hi y'all. So we are in week 1, day 5. I'm gonna do part B and you're gonna do AC in class. So let's get started. Let's see, can I zoom in? Yes, I can, haha. All right, so looking at this function, we know it flips down. So there's the first thing that we know. I know that if it flips, it's gonna have a negative A value. It looks like our new vertex here went to the right 2. Maybe it's a good idea whenever we see a graph we should put in our parent function. So let me just slide that in there. Over 2, up 4, over 2, up 4. You go again, you can do over 3, up 9 right here. And it has butterfly wings on the other side. So here is my original graph to the best of my ability. Now checking out this one. It moves to the right, it flips down. Let's see if it's still going over 1, up 1. In this case, it'd be over 1, down 1. Over 1, down, it doesn't quite hit that. So let's see. It's supposed to go over 1, down 1, over 2, down 4. Let's see if it goes down 4 when we go 2 units to the side. 2 units to the side, it doesn't. It goes down 2. So this one goes over 1, down some kind of fraction. It goes over 2. It looks like it goes down 2. It's supposed to go over 3, down 9. Let's see what happens when we go over 3. 1, 2, 3, down 1, 2, 3, 4-ish. It might be 4.5. I don't know. What happens when we go 5? Over 5, it's supposed to go down 25, because that's 5 squared. Over 5, 1, 2, 3, 4, 5. It doesn't. So this tells me it's got a wider function. It's supposed to look like this. It looks like it got wider by some fraction. Since this went from over 2, down 4 to over 2, down 2, it looks like it got cut in half. So I have an A value of 1/2. So I'm going to be writing f of x equals 1/2, because it has a compression, it's getting wider. It flips, so it's going to be negative. My x moves to the right 2, so that means my h is going to be subtracting. And it doesn't move up or down at all, so I could put +0 if I want to. But we know that if it's +0, we don't really need to include that. So there's our function for this one. Let me zoom out a little bit so you can see everything that I was doing. All right, let's do 2b. According to this one, it wants us to have a stretch of 3, and our A value is bigger than 1, so it's going to be skinny, or it's going to be thinner. I'm going to have a vertex of HK. I'm going to change the sign of H. I'm going to keep the sign of K. So here's H and here's K. I'm going to change H, make it a +4. I'm going to keep K, make it a -6. So let's start by putting in our 4, -6, which is about right there. Since it has a stretch factor of 3, instead of going over 1, up 1, I want to go over 1, up, multiply that by a factor of 3, 3. So I'm going to go over 1, up, 1, 2, 3 dots. Instead of going over 2, up 4, I'm going to go over 2, up, multiply by a factor of 3, I'm going to go up 12 units. So starting here, over 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That puts me right there. Okay, so what I do on this like I do on the other side. So I'm just going to copycat that butterfly wing. Copycat that butterfly wing. So our graph is now skinny like so. It's good to make little notes to yourself off to the side what each elements of this is doing for it. So like when you go over to part C, it has a stretch factor of 1/2. It's gonna face upward because it's positive. I'm calling it a stretch, but it's really a compress because it has a fraction for your A. Here's my H and here's my K. So I can put that information on the graph. In fact, I'll just do this one for you guys. So we have an HK at my vertex is going to change H and keep K. -2 up 3, right there. Instead of going over 1 up 1, I'm going to go over 1 up 1/2. Instead of going over 2 up 4, I'm going to go half of that over 2 up 2. So I'm going to go over 1 up 1/2, over 2 up 2 whole units. Copycat on this side. Instead of going over 3 up 9, I'm going to go over 3 up half of that, which is 4.5. 1, 2, 3, 1, 2, 3, 4.5. 4.5. So there is my wider graph. I know it's wider because if I were to put my parent function in, it originally looked like this. And it got opened up, it got wider. Okay, now number 3. Find the quadratic equation given the vertex and point. Leave your answer in vertex form, no problem. So in vertex form, I'm gonna take this coordinate, call it my HK. So I would have y equals a times x minus 2 plus 0. I put in my 2 and 0 in for HK. Remember, my equation looks like now I know it has to pass through 1, 3. There's my x and my y, but I don't know what my a value is. So I'm going to plug these values in. I'm going to put 3 in for the y. I'm going to put 1 in for the x, and everything else is going to stay the same. And I'm going to solve for a. 3 equals a times 1 minus 2 is -1 squared plus 0. I don't need to write that because plus 0 is just plus 0. Doesn't affect my equation. Then I would have 3 equals a times -1 squared is just +1. A times +1 is just a. So my equation, now that I know what a is y equals 3 times x minus 2 squared plus 0, but I'm not going to write plus 0 because I don't need to. So I had this part, I solved for a, and then I put a into the equation. Let's try another one. Using right here, here's my HK. I'm going to use that function. Y equals a times x minus h. So if I did x minus a -3, that double minus becomes positive. That's why we changed the h. I'm going to add 4 at the end. Okay, I got to figure out what a is, so I'm going to plug in 0, 0. Oops, plus 4, that should be a 4. I'm going to move this 4 over. 3 squared is 9. So I've got -4 equals 9a. That's an a right there. Divide by 9, divide by 9. I get a equals -4/9. Now that I know what a is, I can put that back into this equation, and my final answer is y equals -4/9 times x plus 3 squared plus 4. I'm happy that they're not asking me to graph it because that looks a little ugly, but we can still do it, right? This negative tells me it's a flip. This fraction, it's less than 1 but bigger than 0. So if it's a fraction, it's going to be wide or wider than the parent function. It goes to the left 3, and it looks like it goes up 4. Cool. All right, let's flip the page. Okay. Babe Ruth, the baseball player, hits a major league pop-up so that the height of the ball in meters is modeled by the function height in function of time equals -5 times parentheses t minus 3 squared plus 46, where t is time in seconds. What is the maximum height of the baseball? So we got this baseball player who hits a ball off into the field. Eventually it's going to come back down. So here's like a little model picture of it. What's the maximum height of the ball? Well, up here, eventually it's going to turn around and change directions and fall back down. What do we call that point at the very top? It should be a vertex, which means we're looking for h, k. So in this equation, we're going to change h and keep k. Our vertex is at 3, 46. So the maximum height of the baseball is 46 units high. The reason why I'm using units and not feet or inches or whatever, they didn't give me any details about inches or miles or feet or whatever you want to do to measure how tall the ball is, but I do know that the highest point happens 46 high, and it happens at 3 seconds. What time does the baseball reach maximum height? 3 seconds. I know this because my h is represented by a t, and t represents time. Determine the height of the ball at 2 seconds. So it's saying when t equals 2. All right, so I'm going to take that function, -5 times 2 minus 3 squared plus 46, and we're going to solve this out. -5 times -1 squared plus 46. I'm running out of room, so I'll change it up here. -1 squared is just 1. -5 times 1 is -5. So when I add these together, I get 41. So my answer, 41 units high. I can't spell high. Determine when the ball is on the ground. So it's kind of saying that if it's on the ground, we're going to have a height of 0. So we're figuring out what's happening right there. So we're going to put 0 in place of the height function. So we've got 0 equals -5 t minus 3 squared plus 46. We want to solve for t to figure out what time is that happening. I'm going to minus 46 on both sides. Now this is being multiplied, so I'm going to do the opposite by dividing by -5. Those 5s go away. I'm going to get t minus 3 squared equals whatever the heck this is. You can do some scratch work or grab a calculator. Negative 46 divided by negative 5 gives me 9.2. So I got 9.2. Then I want to get rid of this power of 2, so the way I do that is taking the square root of both sides. On a calculator, how I do that, I'm going to do second square root 9.2. And my calculator tells me the answer is 3.033. Just put 3.03 for right now. Now, this is not the only answer. We have to imagine that it's going to be plus or minus that. Next step, I'm going to add 3 to both sides. So I get 3 plus or minus 3.03 equals T. Now, if I do 3 plus that, I get about 6.03 seconds. If I subtract that, I'm going to get 0.03 seconds. Now, which one makes the most sense? Well, we know at 3 seconds the highest point. So it's not going to land before that. So that one doesn't make a whole lot of sense. So a little bit more than 6 seconds is when it's going to land and have a height of 0. So my answer is around 6.03 seconds.